Good morning, everyone. My name is Sivamurugan T, and I am a final year mechanical engineering student from Mahendra Engineering College, Autonomous Namakkal. Today, I am going to explain the topic automated assembly line balancing using discrete event simulation. First, let us understand what is an assembly line is. An assembly line is a manufacturing system where a product moves through a series of workstations. At each workstation, a specific operation is performed. For example, in automobile manufacturing, different stations may perform activities such as component assembly, welding, painting, inspection, and final assembly. The main objectives of assembly line is to produce products quickly, efficiently, and within minimum cost. Now, what is assembly line balancing? Assembly line balancing means distributing different tasks among workstations in such as a way that the workload is properly balanced. If one workstation takes too much time to while another workstation remains idle, it creates an imbalance. This can lead to production delays, idle time, bottlenecks, and reduced productivity. So, proper line balancing is very important in modern manufacturing industries. Next, let us understand the meaning of automated assembly line balancing. In a traditional assembly line, balancing decisions are often made manually based on experience and calculation. But in an automated system, computers, sensors, software, and simulation tools can be used to analyze the production process. This helps engineers identify the problems and improve the production system before making actual changes on the probe. Now comes the important concept discrete event simulation. Discrete event simulation or DES is a computer based method changes occurs at specific points in time. When a component arrives at a workstation, when the operation starts, when the operation is completed, or when a machine becomes available, these are considered events. This simulation model represents the actual production system in a virtual environment. The major advantage is that we can test different production conditions without distribute the real manufacturing process. For example, we can change the number of workers, machines, workstation, time production rates or task sequence in the simulation. Then we can observe how these changes affect the overall production performance. Let us look at the basic working process. First, we collect the required production data. This may include task time, machine availability, worker availability, and production quality, the workstation capacity. Second, we create a simulation mode based on the actual assembly line. Third, we assign tasks to different workstations. Then the simulation is run for a specific period. The results are analyzed to identify bottlenecks, idle time, waiting time, workstation utilization, and production output. Based on this result, engineers can modify workstation arrangement or task location. The simulation can be run again to the better solution. For examples, suppose an assembly line have 5 workstations. If the third workstation takes significantly more time than other station, it becomes a bottleneck. This means production may have to wait before entering the third workstation. By using discrete event simulation, we can identify this bottleneck and redistribute some tasks to other workstation. As a result, the workload become a more balanced and the overall production efficiency can be improved. There are several benefits of using this approach. First, it helps to increase production efficiency. Second, it can reduce workstation idle time. Third, it helps to identify bottlenecks before implementing changes the real production timeline. Fourth, it can reduce production costs and unnecessary experimentation. Finally, it supports engineers in making better data-driven decisions. This method is useful in industries such as automobile manufacturing, electronics, consumer products, aerospace, and other mass production industries. To include automated assembly line balancing using discrete event simulation is an effective approach to improving modern manufacturing system. It combines automation, simulation, data analytics, and engineering decision making to achieve better production performance by identifying bottlenecks, reducing idle time, and can achieve higher productivity, better utilization of resource, and improve efficiency. Thank you everyone for listening to my presentation.